Welcome to The Explainer. You know when you're talking to an AI chatbot and it feels like it has the memory of a goldfish? Like it completely forgets what you just said a second ago? Well, that's a real problem. And today we're going to break down exactly why that happens, and then we'll get into the brilliant solution that finally gave AI a proper long-term memory.
Okay, so here's the game plan. First, we're going to look at a simple sentence that can totally trip up a powerful AI. Then, we'll dive into why it's so forgetful. After that, we'll introduce the hero of the day, something called an LSTM, and see how its genius design completely changes the game.
All right, let's kick things off with a simple challenge. One that can completely stump a pretty common type of AI called a recurrent neural network, or an RNN for short. Now, these things are specifically built to handle sequences, like words in a sentence. But, and this is a big but, they have a huge critical flaw.
So you might be asking, how in the world does a powerful AI mess up a simple sentence? Well, it all boils down to one thing: memory. See, to give you the right answer, it has to remember the context, what came before. If it can't do that, it's basically guessing.
Okay, check out this phrase, the writer of the books. The main subject here is writer, right? That's singular. But look what's right next to the verb, the word books, which is plural. And that's where the AI starts to get really confused.
So a basic RNN, it's probably going to get this wrong. It'll say R. Why? Because it gets totally distracted by that closer word, books. And it just completely forgets about the actual subject, writer, from way back at the start of the sentence. And this right here shows its biggest weakness. It has a terrible memory.
Okay, so what's really going on under the hood here? Why is it so forgetful? It really comes down to how these AIs actually learn. So when an AI makes a mistake, it has to learn from it, right? It does this by sending a little error signal backward through the sentence. This signal is called a gradient, and you can think of it like a little note being passed back in class, whispering, "Hey, you messed up back there. You need to change a little bit."
But here's the catch. For the AI to fix a mistake that happened at the end of a long sentence, that little error signal has to travel all the way back to the very beginning. It has to pass through every single word. And this creates a super long chain of math calculations. And trust me, these long chains, they're a massive problem.
And this is where it all falls apart. Imagine that at every step back, that signal gets multiplied by a number that's less than 1, say 0.5. Well, with every single step, that signal gets smaller and smaller and smaller. It's not just shrinking, it's shrinking exponentially. And just look at this. After only 10 steps, just 10, that signal has practically vanished. It's basically zero. So what does that mean? It means the AI can't learn a thing. The message from the end of the sentence literally disappears before it ever reaches the beginning. The AI has no clue it made a mistake.
But wait, there's more. That's not the only way this whole thing can go haywire. What if, on the flip side, the numbers you're multiplying by are bigger than 1? Well, then the signal doesn't shrink. It explodes. It just grows and grows exponentially, completely out of control.
And the result? You get a signal that's just ridiculously huge. This causes these massive, chaotic updates inside the AI's brain that just wreck any useful learning it's done. It's kind of like trying to perform delicate surgery with a jackhammer. You just end up destroying everything.
So we're kind of stuck between a rock and a hard place, right? The learning signal either vanishes, so the AI is a forgetful goldfish, or it explodes and the whole thing goes haywire. So how do we fix this? How do we build a better memory for our AI?
Well, for that exploding signal, the fix is actually pretty straightforward. There's a trick called gradient clipping, which is basically just putting a ceiling on the signal. It says, nope, you can't get any bigger than this. Simple enough. But for the vanishing signal, that's the real beast. For that, we need a hero. And that hero is called the long short-term memory cell, or as everyone calls it, the LSTM. So what's the big deal with this LSTM? What makes it so special? It's all about its design. It's not just a simple neuron. It's more like a really sophisticated little computer memory chip. And it has these special things called gates that act like bouncers, carefully controlling what information gets in, what stays, and what gets kicked out.
You know, the best analogy is an information superhighway. A normal RNN is like a single clogged city street where all the traffic, important and not, is stuck together getting jumbled up. But the LSTM, it builds a special express lane. It's called the cell state. And this lane is just for the really important information, letting it zoom right through, totally protected from all the traffic and noise.
Now this express lane isn't a free-for-all. It's got 3 super smart gatekeepers managing it, and each one has a very specific job. Deciding what information is important enough to get on the express lane, deciding when old information needs to get off, and deciding what information gets shared with the rest of the AI at the right moment.
First up, we've got the forget gate. Think of this one as the cleanup crew. It looks at the information that's been cruising along in the memory lane and asks, hey, is this still relevant? So, for example, if a story was about the cats and now it's about the dog, the forget gate says, okay, time to forget about the plural cats, we're focused on the singular dog now.
Next, there's the input gate. This one's job is to decide what new information is important enough to get into the VIP section, that protected memory lane. So, going back to our sentence, when the LSTM sees the word writer, the input gate's eyes light up and it goes, whoa, that's the subject, that's important, let's save that.
And last but not least, we have the output gate. This one is like a precision instrument. It looks at everything in that nice, clean, long-term memory and carefully picks out the exact piece of information that's needed for the job right now. So when it's time to pick the verb, it reaches in, grabs the memory of writer, and says, aha, the subject is singular. We need to use is.
So this is the real magic of it all. When you combine that protected memory highway with these 3 super smart gates, the LSTM can hang on to a critical piece of information for a really long time. Hundreds, maybe even thousands of words later. And that important info doesn't get watered down or lost along the way.
And this brilliant design? It's the perfect fix for that vanishing gradient problem we talked about. Because the important memories are on that express lane, the error signal doesn't have to suffer through that long, painful chain of multiplications. It's got a direct, clean path back. That means the learning signal can make the trip all the way back to the beginning, totally intact.
All right, so let's circle all the way back to our original problem. The AI with an LSTM reads the writer of the books, and its input gate immediately goes, yep, writer is important, and tucks it away safely in its long-term memory. Then it doesn't matter how many other distracting words come in between. When it finally gets to the verb, the output gate just pulls out that memory and says, the subject was writer, so the verb has to be is. And just like that, problem solved.
I mean, this ability to remember context across these huge distances, it's absolutely fundamental. It's the magic behind so much of the AI we use every single day. From your phone's chatbot to sophisticated language translation, it was a total game changer. And, it leaves you wondering, if this is what a better memory can do, what other incredible human-like abilities, like really getting sarcasm or following a complex story, could we unlock with an even smarter memory?